Let's discuss today how to write the equation of a line if you are given a point and a slope. So please note that the given information is a point that's on that line and the slope of that line. So recall that you can use either form that you want. You can use the slope-intercept form, or the point-slope form. Either one that you prefer is acceptable. Let's do it over here in slope-intercept form. That way my hand doesn't get in the way and smear the writing. If I know the slope is 2/3, then all I need to have now is the y-intercept. I can find the y-intercept simply by plugging in the values for x and y that I know will satisfy the equation I'm trying to write. So I'm going to replace y with -1, the slope with 2/3, and the value of x with 3. And if I just simply solve for b here now, I know the y-intercept. I've already been given the slope. I can write it in slope-intercept form. So I'm going to multiply 2/3 times 3, which should give me 2. And now to solve for b, simply subtract 2 from both sides of the equation. And b is equal to -3. So I use the fact that I know the slope is 2/3, the y-intercept is -3, y equals 2/3 x minus 3 is the equation of the line that passes through the point 3, -1 with a slope of 2/3. For those of you who prefer the other method, it's called the point-slope form because the given information to you is the point that's on the line and the slope. So I'm going to replace x1 and y1 with the points. So I will simply replace y1 with -1, so I have y minus a -1. The slope is 2/3, so m becomes 2/3, and x1 becomes 3, that is the point that is on the line, minus 3. Don't forget that subtracting a negative simply turns into adding a positive. I'm going to turn this into the slope-intercept form because that's the way we prefer to write our equations. So I will distribute 2/3 first. 2/3 x minus 2. And last thing I have to do to get y by itself, to put it into the slope-intercept form, is subtract 1 from each side of the equation. And I'm left with y is equal to 2/3 x minus 3. So let's try another one. Let's say now our line is, now our line goes through the points -4, 5, but has a slope of 1/3. So let's do it in point-slope form first. y minus y1 is equal to m times x minus x1. So I'm going to use my y and x value from the point, my y1 and x1. I'll rewrite this as y minus 5 is equal to 1/3 times x minus a -4. And right away I'm going to change my subtracting a negative into adding a positive. I'll change this into slope-intercept form by first distributing the 1/3, leaving me with y minus 5 is equal to 1/3 x plus 4/3. And here's where things get a little bit tricky, because when I add 5 to both sides, now I find myself adding fractions. So over here, kind of as a side thought, let's add 4/3 to 5. In order to do that, I have to make 5 into a fraction. And to add fractions, I need a common denominator, so I'm going to multiply the top and the bottom by 3. And now I'm adding 4/3 to 15/3, which should leave me with 19/3, with a final equation in slope-intercept form of y is equal to 1/3 x plus 19/3. Now let's try it over here on the other side of the paper if we decide to do this using the slope-intercept form. Again, I know that if I have the slope and the y-intercept, I can write the equation of a line. I do have the slope, and I have a set of ordered pairs that will satisfy this equation. So I'll find the y-intercept by using this set of ordered pairs. So instead of y, I have 5 is equal to 1/3. My x value is -4 plus b. So all I have to do to write it in slope-intercept form is find out what my y-intercept is, b. I'll start by multiplying -4 times 1/3, giving us -4/3. And just one last thing to solve for b, that is add 4/3 to both sides of the equation. Again, either way I choose, I'm going to have to do this exact same problem, 5 plus 4/3. And I know from over here that b is going to equal 5 plus 4/3 is 19/3. So now I have my slope, I have my y-intercept, I can write it in slope-intercept form. Whichever method you choose, you should still end up with the exact same answer.